Hello all and welcome back. So in this video, let us continue our discussion on linked list. And now let's try to solve one question. Now the question is as in front of us. It is to merge two sorted linked list. Now in this question, we will be given two linked list. And a similar kind of question we have of course done with arrays or list, right? Where we were given two sorted arrays or list and we have to return a single array where all the elements are there. Now, in this question, the approach is going to be exactly the same. We have to make sure that my final linked list, which I will be returning, that is having all the elements and they should be in the sorted order, right? Now, the question is very important. You can see that how it is asked in many companies like Amazon, Uber, Apple, right? So it tests you on a lots of skills, how good you are able to handle this. A very good industrial use case, which I can even think of this particular question, is let's say tomorrow, if you have to merge two sorted playlist, right? So let's get started, everyone. As a good habit, first let us see what should be the answer. So the answer, final answer should be something like this: 2, 3, 5, 6, 7, second, 9, and 10, right? 10 and 17, and finally 9. Great. So this is going to be our final answer, everyone. I can say that this will be the final head I'm going to return, right? Now, if we think in terms of linked list, again, there is no space or something which we have to allocate. We just have to give the right pointers. These elements are anywhere randomly allocated. So if I'm able to join them properly just by playing along with the pointers, we will be able to return the sorted linked list, right? So here you don't have to actually create a linked list where you have to create nodes, right? You don't have to create these nodes. They are already there in space. We just have to make sure that we are able to make their connection right. Okay, great. So now let us do the same thing, everyone. Let us try to see what approach we are going to follow. And I'm also going to write few things which we should be careful about. The very first thing, okay, we should always in these type of question make sure to handle none properly. Okay, because we will be accessing the data as well as the next. So this none should never be encountered. Okay, that's the very first thing. Now let us see what exactly is going to happen, everyone, how we are going to handle this thing. The way to do that, and let me copy this input overall so we can use that. So yeah, let's say I have this particular input here. The way I'm going to reach to this question, everyone, is by making two variables, right? So let me make them in this color so they are visible. It's going to be final head and final tail. I will be going to each and every node, comparing its value, and based on that value, just making my head or tail update, right? So for example, let us start. Initially, we will compare head 1 data and head 2 data, right? So as of now, of course, the first one. Now you can just actually see this question as you are trying to make your input of linked list, right? We did the same kind of a thing where we took a head and a tail. Initially, of course, we can see that final head is going to be none. That is something which we used to take, right? So it's going to be none. Now, since it's none, I have to check and make sure. Now, in the final linked list, if I just see, I know that my final head is going to be this 2 only, right? Whichever is the smaller. In a very much similar sense, when I compare this 2 and 3, I know that my final head is going to be 2, right? So what I can do is final head, final tail, right? So this is what initially both of them are going to be. Once I have done this, my head 1 should move here, while head 2 is here only, right? Great. Now again, I am going to compare these two. I'm going to compare these two this time. And now what I'm going to do, I'm going to move my final tail here. Final tail will be moved here. And I'm going to make this connection. I'm going to make this connection. And in a very similar manner, H2 is going to move here. Right? So we are just moving our pointers one by one, the head pointers of the list, comparing their values, and then making our final list. Now this time, I'm going to compare 5 and 6. Okay. I know that 5 is lower. So this time, let us make our final tail here and join our list like this. I'm not actually breaking any connection. I am not making any new nodes. I am just seeing that which are the nodes which needs to be connected. Okay, great. In a similar manner, now H1 will move forward, and this is very similar to the approach which we used in our arrays or list, where we used to take two pointers, I and J, and keep on incrementing them, right? Great. So now again, I'm gonna compare these two. I'm gonna compare these two, and I can say that this time this connection should be made, and final tail should move here. Again, very similar approach, the one which we followed in the take input, and that's the reason. Like I kind of asked you to write all those operations. Okay, great. So H2 has now moved here. Okay. Now I'm gonna make sure that I compare these two. I compare these two. Here we can see that H2 is lower. So let us join this particular thing and move our final tail here. Okay, great. And now I should move my H2 this. Now if you see this particular case actually, we have our H2 equals to none. Okay, we have our H2 equals to none. Let me just draw it like this. H2 becomes none. Now, of course, I cannot compare anything, right? Now I cannot compare anything. Now, if this is the case which I have reached, what I should do is a very easy thing. I should just make this connection. Whichever head is not none, I should just connect that to my final tail. And all these connection will be there with me. All these connection will be there with me. So I don't need to do that. And just if I can zoom, make it a little bit non-messy for you all. Just let me try. See everyone. So now if you will see, this is the linked list which I'm getting. Like this, which you will see is in a sorted manner. 2, 3, 6, sorry, 2, 3, 2, 3, 5, 6, 7, 9, 10, 17. Right? So I hope this is clear, everyone, the way we are doing it. Again, a similar kind of an approach, just few things we have to handle, and especially the case of none. Okay, great. So let us try to code this quickly, everyone. So now let us see the code. First, I'm importing everything. So from common, I just need to import star. So importing all the functions. Now let us create a overall merge to sorted linked list, right? I will be getting a head one and I will be getting a head two, and that is all I'm getting. Okay, great. So now what I have to do, everyone, pay attention. Now exactly what I have to do. First, also take a case where one of the linked list is empty. Okay, so what I'm saying is, let's say one of these is empty. You're not getting head 2. You're just getting head 1. Don't you think then we should just return head 1 as it is? Because this is going to be my final linked list then. If this particular linked list is empty, I don't have to make any connection or anything. It's the same as if you are given two arrays and one of them is empty. The other one is the sorted one, right? So if head 1 is none, return head 2. Similarly, if head 2 is null, return head 1. Okay, great. So now final answer, sorry, final head equals none, final tail equals none. Great. Now pay attention everyone what I'm going to do, because this is the first uh, question or first overall video where we are handling two linked lists, right? So while head 1 is not none and head 2 is not none. So very first thing is I never have to call anything on none. So please make sure that you have this condition in place and you understand why I'm adding this. Again, now I'm going to compare my data. If head1 dot data is less than head2 dot data, what does that implies everyone? So we just did a dry run here, right? If my initially in the very initial case, head1 and head2, if head1 data is less, then that will be the element which I have to add in my linked list, right? And if you remember, when we were writing the code for take input of our linked list, we used to check if our head, final head is none. If it is none, then we need to make sure that first we are implementing that. So final head equals head 1 and final tail equals head 2. Sorry, head 1. Both of them are going to be the same. If this is not the case, then that implies that we are somewhere in the middle of our answer. Head should not move. Head we need to make sure that we are able to return. But final tail dot next should be the head 1 and final tail should become head 1. Now again, you will remember this particular case from here. If let's say we are on this particular node, then if I have to join this, first I used to make this connection, then I used to ask my final tail to go there, right? This is something which we even did when we were try running the code. Great. And irrespective, once I have done this operation, I should move my head 1 to the next. Now just head 1 is to be moved, not the head 2. Else, when the other case is there, this is going to be a lot same. The logic is going to be the lot same, just that this time it will be head 2. The reason I hope you understand very easy. Same thing I have to do just for head 2. This code will now run till we have reached end of any one of the linked list, right? So now what we have to do, everyone, pay attention. Once we have reached to it, if head 1, if head 1 is not none, if head 1 is not none, then we just have to say final tail dot next is equals to head 1. We just have to join this. This is the case of particular this node. When head 2 became none, I checked that final tail, I should just make this connection. After that, everything will be handled, right? So in a similar way, just writing this code for one more. If head 2 is not none, final tail dot next equals head 2. And I have to just return final head, because that is where my main linked list head is. Let me just zoom out it so that you can see this code. Okay, I hope the whole code is clear. I'm going to explain it once again. If either of the linked list is none, just return the other one. Take, just like we were taking input, where we were taking that head and tail will be none initially, define them. Now try to make your overall linked list. These, the node which you will be adding will be based on the values. So I'm calculating the data here. Then just the similar way, if head is none, initialize our head, else just handle the tail, because head is going to stay where it should. Head will not move forward from 2, right? Great. So I think we have handled the cases, each and every of these case, because of this none condition is going to run fine. So let us try out our code, everyone. Merge sorted linked list. Let's say head 1 is equals to, what was the function name? Yeah, create linked list for list. Create linked list from list. So it should be 259 10 17. 259 10 17. Head 2 create from list 367. 3, 6, 7. Then final head, merge to sorted linked list, head 1, head 2, print ll, final head. Okay, so great everyone. This is how we should write the code. Now let me just run this quickly. Second, or let me run this in terminal, though should be fine anyways. Yeah. Okay, so let me clear this. Great. I think we are able to get an answer. 2, 3, 5, 6, 7, 9, 10, 17. Right? So the answer seems to be coming. Maybe we can just print our other linked list as well meanwhile. So now you will be understanding how these all the questions, all the functions which we wrote, how helpful they are to us, right? So nothing we are importing, just running them by using that. See, 2, 3, 5, 9, 10, 17, 3, 6, 7, 2, 3, 5, 6, 7, 9, 10, 17. Let us check for few cases. If this is none, let's say in this case, then let us run this. Seems to work great. This is the answer. If this is none by any chance, and head 2 is there, again seems to work great. This is our final answer. And let's say just both are none. Yeah, so we are not getting anything like this. Actually, we are creating head and asking it to be printed. So that's why we are getting this. But yeah, I hope this is clear, everyone. Just to make sure, because this is the first of a question of this kind, let us just try to visualize it a little quickly. Okay, let's remove this middle part and everything. What all we have to do here, everyone. So let us remove this. Again, everything is same. Just I think we are creating from list. Yeah. Great. So let me help you visualize this, everyone. Again, I want to make sure that these kind of question you are able to visualize properly. That's why I'm putting in so much visualization in place. It's saying an error. The error is println is not defined. No worries. Let us do one thing. Actually, we can just get rid of println. We don't need that, right? If we are able to see them, we should be good with that. Great. So cool, everyone. Let us quickly run this. And yeah, please make sure that you understand this properly, right? Let us first get the list. So I'm just running it till we are able to get the list. And great. So 1 second. Okay, have we removed the last line? What? No, great. So yeah, this is the list which we have, everyone. Pay attention. Head 1 and head 2. This is where I have my list. Now let's move forward. Okay. If we have passed, okay, my bad. I'm not past the head 1 and head 2. So just a second. Head 1, head 2. Now let us visualize. Great. So let us just get to the end where we have the lists. So this is where, everyone, we have created the list, right? You can see the list in front of you. Now, majorly you have to focus. Let me zoom out a little bit. Majorly you have to focus on how these connections are getting changed, right? So all the game is of connection only. Let's move forward. So merge to sorted linked list. Head 1 is none. Head 2 is none. No, both the cases are not right. So now let us move forward and see. Final head, final tail. Great. Now, while head 1 is not none, it is not. Head 2 is not none, it is not. If head 1 data less than head 2 data, 3 and 2. Head 1 is at 2, head 2 at 3. I think 2 is less. Okay. Final head, see how it's going to get connected. And final tail as well. Right? Great. Now head 1 is going to be on the next node. That is where head 1 has moved. Again, if we go forward, head 1 dot data less than head 2 dot data, no. This time 3. Right? But now final head we have already set. So we can just change the tail and see this connection, how it will break and make it formed here. See. So yeah, I guess it becoming a little bit messy, but see, this new linked list is getting formed. This has been disconnected and we are now forming this new linked list, right? So let us move forward. It will become a little bit more clear. Again, head 2 has moved to the next one. Sorry for so many pointers, but yeah, That's how, like, I want to make sure that you visualize this. Okay, great. So again, head 1 data less than head 2 data. Head 1, I see it as is on 5. Head 2 I see is on 6. 5 is less than 6, right? So I will be now joining this node. See how it's going to happen. Final head is not none. So final tail gets joined here. Okay, a lot messy, no worries. Final tail, something like this. And it is becoming like this. So 2, 3, 5. Okay, all the list is here. And the other list part is here. Let's move forward, everyone. Now final tail is also moved. Okay, head 1 is here now. Now if I move forward in a very similar way, this time again, head 2 is less. Where is head 2? Head 2 is on 6. Head 1 is on 9. So 6 is less. So I'm going to make sure that this final tail, right, this gets connected this time. So it's going to be a lot messy in the memory, right? I hope you understand that. Like in the memory, it's going to be a lot messy. Head 1 and head 2 are moving forward, but we have to just see our final head where the overall list are getting made. Okay, so pay attention everyone how it's getting made. Final head we follow 2 and your 3, it's going to 5 and I see that it's going to 6. Something, it's still sorted. Every time it's going to be sorted, right? Great, let us move forward. Head 2 has moved now. Let me remove everything as well. Great. This time again, head 2 is smaller. Head 2 we have on 6, 7, and it is 9. So head 2 is smaller, it's going to get joined, right? And now overall head 2 has become none. Once head 2 has become none, we can come out. Okay. If head 1 is none, it's saying head 1 is none, no. So then just connect head 1 as well. See. Now a lot lost, but don't worry. Let us follow this. Head, final head, this 2, 3, 5, 6, 7, 9, 10, 17, right? So a lot messed up. Lots of pointer in the memory, but no worries. Now let us move forward. Return the final head. And now we can see how list is, right? We can just even remove this head 2 as well. Another head 1 as well. Now see the final list, how it is getting made. 2, 3, 5, 6, 7, 9, 10, 17. Now the reason I want to show you this is that I want to explain you one thing. Nowhere in this we change the memory. We just played with a lots of pointer. And again, it get a little messy here. But in our arrays or list question, we were adding or creating new elements. Here we are able to just handle the same memory by manipulating the pointer. So I hope with this exercise, with the effort which I have put, you are able to see that how these nodes, they stayed where they are. We don't have to change anything in them. Just if we can change their pointers, we can actually manipulate a linked list. And again, that is a lot, I think, memory efficient, right? You have not created any new memories. So overall, that is a lot memory efficient in many languages. Okay, great everyone. So the overall visualization is a little bit messy. I won't say that it is difficult or complex because we have seen the same here as well. It's pretty straightforward to understand. Just one thing more, as this has been asked in a lot of companies, I will expect that you will try to solve this question. So this is a question in lead code as well. Okay, merge to sorted linked list. Even if you try to just copy the code, it will work. So I expect that you will be working on this particular question. Let me add this link here. Okay, so this link is here so that you can try it out at your end as well. 1 second. Great. Okay, everyone. So I hope with this, the overall approach, the visualization, and the complexity involved is clear. If this is, then congrats. You have just understood a very good question asked in so many great companies. Okay, everyone. So great. Then let's meet in the next video. And please make sure that you practice this once and try to understand the pointer manipulation, how it is happening. Okay. Thank you.